Welcome back to this course, Java, the Intermediate Level, a presentation of Coding Bootcamps. In this session, Session 6, we're going to talk about developing software using Java. We'll discuss the tools and the environments for developing software using Java. Just to recap, in our previous session, we talked about the fundamentals of characters and strings, string classes, string operations, the string builder class, the character class, the string tokenizer, and regular expressions. In this session, Session 6, we are going to discuss developing software using Java. We'll go into applications, applets, and web components. We'll talk about the different Java development environments, also the Java development kits, compiling and running from the Java command line, the main method, package and import statements, jar files, class loading, and the class path, and Java integrated development environments. So here we'll discuss Java applications, applets, and web components. The Java applet is considered to be Java's first web technology. It's actually a Java class that is downloaded and executed within a browser. So it was something like a video or ActiveX component. It got a lot of attention. Applets could run entirely client-side or connect back to the server. It was downloaded from and it was a send to and receive data type of client. A Java servlet is actually a web page. It was Java's first server-side web technology, meaning the web page was run from and built entirely on the server and sent back to the user running the browser. Java servlets were developed and largely replaced what were called CGI scripts, which were executed against the browser, built in a language called Perl or C. A servlet is a web page. When it's looked at, it doesn't look like your typical web page because it's a lot of Java code, but it indeed executed the logic to build a web page and send the requests back to the user in a form of a readable web page. A web client consists of two parts. Dynamic web pages containing various types of markup languages like HTML and XML. They're generated by web components running on the web tier and the web browser itself, which renders the pages received from instructions from the server. So a web client is sometimes called a thin client, and thin clients usually do not do things like querying databases or execute complex business rules. When you use a thin client, heavyweight applications and operations like those are offloaded to the enterprise beans executing the Java 2 Enterprise Edition server, where they can leverage the security, the speed, the services, and the reliability of J2EE or Java 2 Enterprise Edition server-side technologies. So with web components, J2EE web components can either be servlets or JSP pages. So again, a servlet is essentially a web page, and a JSP, a Java server page, is also a web page. Servlets are Java programming languages classes that dynamically process and construct HTTP responses. So they process HTTP requests from the user and respond back to the user and build web pages. JSPs, or Java server pages, are text-based documents that are part of or are related to servlets, but allow a more natural approach to creating static content. So they look more, when they're built, they look more like web pages and do contain static content. It's not all dynamic code that responds to requests. Static HTML pages and applets are bundled with the web components during application assembly. So these are things like images, but are not considered web components by the J2EE specification. Server-side utility classes can also be bundled with web components like HTML pages, although, again, the static HTML pages are not considered to be web components. Like the client tier, and as shown in the figure on the next slide, the web tier might include Java beans and other components to manage the user input and send the input to the enterprise beans level for running business logic and other processing. And our typical web tier for J2EE server building and running web applications, we have on this layer here, we have our JSP pages and servlets, both web pages that are responding to and taking requests from a web browser. There are going to be times where processing is offloaded to the Java Bean components for, again, that speed and that processing. Business tier could include images and also data processing. Java, or the Java virtual machine, comes in what they call flavors, and there are 3 flavors of Java. There is the Java SE, or the Standard Edition. There is the Java EE, or Enterprise Edition, and the Java ME, or the Micro Edition. The Java SE, or Standard Edition, is the base or the foundational edition. It contains all of the libraries and APIs that any programmer should learn to build project level or highly localized Java application. The Java EE, or Enterprise Edition, is for business, for large-scale distributed systems that meet the demands of business. It's built on top of Java SE and provides libraries for database. JDBC is a very popular connector for Java to databases. Remote method invocation, messaging, web services, XML processing, and defines standard and enterprise level APIs for Java Beans servlets, portlets, and Java server pages. The Java Micro Edition is more for developing applications for devices, so it's more embedded applications such as mobile devices, embedded systems such as set-top boxes. Java ME provides a subset of functionality of Java SE, but also introduces libraries for the hardware for these specific mobile devices and smaller devices. Because Java ME is based on an earlier version of Java, some new language features were introduced into Java 1.5 and may not be available. So just be aware that it may not be as flexible or have all of the features and functionality as Java Standard Edition. Let's go over installing the Java Development Kit. So the Java Development Kit also includes the Java Virtual Machine, which is the Java SE, Java 2EE that we just discussed. We'll also discuss setting our Java Home environmental variable, and this example will be for Windows, but this can pretty quickly be moved to Linux as well. First of all, we want to install the JDK software, so you can, there's a variety of links available to download Java software or the JDK, so go out and search and you can find a variety of links. We want to select the appropriate JDK to download based on your needs. The JDK software is installed. It runs through an installer. It doesn't take very long. It's a very typical installation. And you can move the JDK to any directory on your system. So when you first install, for Windows, it does want to go into Program Files, and it will indicate a directory with the version. However, again, you can select any location. Then we want to set the Java Home based on this location. So any applications or any other tools that use Java will know where to look for Java right away. So we're going to set this location to Java home. So this is an environmental variable. In order to set this, you can right-click on My Computer on the Windows desktop, go to the Advanced tab, select Environmental Variables, and then Edit Java Home, and point to where the JDK software is located. In this example, again, this is where we installed the Java development kit. Also, your path. So you may want to check your path variable as well. And with path, you will append the bin directory to this path. But this is what we will use for our Java home. Here we'll discuss running and compiling Java from the command line. We're not doing any coding here. But what you want to do is set into a directory. So you can see we're setting into a directory. And we already have a file with our application or with our class in it. In this case, it's helloworld.java. We dynamically set the path here. So you can see here it goes down to the bin, just like we talked about in the previous slide. Then we call a command javac, which is the compiler. So we call the Java compiler on our Java class or our source code. The Java compiler runs, and if you'll get some output, but we'll also see that javac, if we type dir, has created a new file called helloworld.class. So it'll have the same name as our Java file, except instead of a Java extension, it will have a .class extension. And you'll also see the helloworld.java. And in order to run from the command line, we'll just type not javac, but Java, and the name of the file. And this will call the class file. And then we'll see the output back to the console of Hello World. Let's talk about the Java main method. So our Java program, the execution starts in the main method. This is where all of our other classes are instantiated. A Java program starts executing in the main method. You can choose the name of any class to begin your execution, but the main method will always be called the main method, and it has to be there. Very, very similar to C and C++. The main method has a very standard way to be built. It has the public, static, and void up in the header, and so we can see here public, static, void, but it also is accepting an array, and there are different ways besides the standard way to pass parameters to customize the execution of our Java application. However, we must always pass a string objects or string arrays to the main method. That is a rule. Like I said, it can be customized, but the main method only accepts string objects or similar to string arrays. So exactly similar to C, C++, and many other programming languages, reuse is a big part of programming. I think every programmer knows that. We don't want to always have to go back. If we're using any kind of network resources, we don't want to add the code and reprogram a lot of objects which have already been developed for working over a network or for any other types of resources that we need. Java is no different. They give us libraries, and so we can actually import or reuse existing libraries. So under Java, we have several different packages or libraries that we can install and instantiate these objects in our code, so we can reuse I/O or input-output to take advantage of external files that we may want to use, or AWT to take advantage of Windows-based, so we can actually have Windows-based programs. We can take advantage of Windows libraries, so we don't have to go through all the steps to recode building a Windows type of interface. Here's an example of creating a Java package. So what we do is we simply use the package command followed by the name of the package, and after that we have our source code, which we look to include in the package. A package then is ready for reuse once it's built, and then other developers will use the import keyword to import the user-defined packages. So again, it can be reused in other Java applications. So let's discuss jar files, class loading, and class path. A Java archive or a jar file is a file format that enables you to bundle many files into a single archive file or jar file. Typically, a jar file contains the class files, libraries, and other dependencies associated with running the applications. So many times, not always, but quite often, a jar file is the equivalent of the traditional executable file, where not only the application is compiled, but all of its external libraries are also brought in to that file, so the file can run completely independently. The jar file format provides many benefits. Here are some examples. Security from the perspective that the jar file is binary code. So users who recognize your signature can optionally grant that your software privileges will be used the way that you intended to be used, and nobody can take your intellectual property. Also, decreased download time. So because a jar file is compressed, and because it has all of the libraries, it will come down very quickly and be ready for execution very quickly. And also compression. So the jar format allows you to compress the files for very efficient storage. Jar files support packaging for extensions, so that extension framework provides a means by which you can add functionality to the Java core platform, and the jar file format defines the packaging for extensions. So by using a jar file, you can turn your software into other extensions as well. And package sealing. So packages stored in jar files can be optionally sealed so that the package can enforce version consistency. This is very important. Sealing a package within a jar file means that all classes defined in the package must be found in that same jar file. And also package versioning. This can be actually key for compliance. So a jar file can hold additional data about the files it contains, such as vendor and version information. And also portability. So there is a standard mechanism for jar files. It's a standard part of Java and the API core, and jar files will be able to go from machine to machine, Java virtual machine to Java virtual machine, so jar files are highly portable. Getting classes introduced to the Java environment can have a few challenges. So classes are introduced to the Java environment when they are referenced by name in a class that is already running, hence the main method. So the main method is almost a configuration type of class that is a class that's already running. We declare the main method as static and taking that string array as the argument. But once that class is running, future attempts at loading the classes are done by something called the class loader. So the class loader is actually established by our, partly established by our main method, a class that's already running. And just to make it simple, a class loader creates a flat namespace of class bodies that can be referenced by a string name, and the method definition is right here. So the class name contains a value, which is a string that's understood by the class loader, and it is uniquely identified as a class implementation. Also, all Java virtual machines include one class loader that is embedded as part of the virtual machine. And this embedded class loader is called the primordial class loader. It is somewhat special because the virtual machine assumes that it has access to a repository of trusted classes which can be run from the virtual machine or the Java virtual machine. So Java natively, the Java virtual machine natively does not know where our Java classes are. So here we'll talk about how the Java launcher finds user classes. So user classes are classes built on our Java platform we're using in our Java development environment. To find user classes, the launcher refers to user class paths, which are lists of directories. It works just like our path directory. That's that environmental variable that's set for Linux and Windows. It's a set of search paths where files may be. Same idea here. So that class path has that list of directories, jar files, zip archives, which contain our class files. So a class file also has a subpath name which reflects the class's fully qualified name. So not relative, fully qualified. So for an example, if the class com, my package, my class, and that's a 1 there, is stored under my classes, then my classes must be in the user class path, and the full path to the class file must be, and it's just simply looking back here for what the class path is. It's under myclasses.com, my package, and then we have the class name. If the class is stored in an archive named myclasses.jar, so a jar file, then myclasses.jar must be in the user class path, and the class file must be stored in the archive as com, my package. So it's just to simplify, a class path is just simply the path to the class that we're trying to call. Again, our class paths are values, string values of where our classes are, no different from the value of our path variable, which is a set of directories where our files are. The classes are separated in the class path, just like they are separated with our path variables. In the Linux world and Unix world, we use a colon to separate the various paths. In the Windows world, the individual classes are separated by a semicolon. The Java launcher puts the user class path string in the Java class path system property, and some possible sources are we see here the default value, which is a space, meaning that the user class files are all the class files in the current directory. If there is defined as an environmental variable a class path environmental variable, it will override any default value. So be aware, if you have a class path environmental variable, you can pass your own class path on the fly or on the command line. So if you use, when you're running from the command line, -cp or .classPath command line option, it overrides both the default value and the class path value. And another possible source is the jar archive specified by the -jar option. That overrides all other values. If this option is used, all user classes must come from that specified Java archive. Please go to the Oracle website. Again, Oracle is the current vendor for Java, and just do a search on the Java API documentations, and sometimes these links get a little dated, so certainly search around and find the current Java API documents. There are many JDK tools like Remote Method Invocation, Java Web Start, and others. So for a complete list, again, visit the Oracle website for Java. And again, you can start with this link, but also search, because sometimes these links do get dated, so you want to make sure that you are seeing the current information. There are many tools for developing Java applications on the market. These tools are called Java Integrated Development Environments. It's highly recommended that you download one and you use one. It's worth it for the syntax highlighting. It's worth it for the visual debugger. Those two are worth the price of admission alone. Many are free, and those are called the community editions. And then there are what they call enterprise editions, which do require a purchase. So for a complete list of the IDEs and feature comparisons, there are various wikis out there. The Eclipse IDE is one that is quite popular. It may be the highest market share for Java development. This is a free product, but also you can search for or go to this Wikipedia page and get more information on a very, very extensive list on Java integrated development environments. So just to summarize, we talked about developing software using Java. We talked about applications and web components, the various editions of the Java virtual machine, installing the JDK, compiling and running Java applications from the command line, the main method, the package and import statements, jar files, class loading and class paths, and we ended with Java Integrated Development Environments, or IDEs. Stay tuned for our next session, where we'll discuss the Java Collections Framework. Again, please consult your learning materials for information on Java private tutoring and coaching sessions. Thank you again for watching this video, and this has been a presentation of Coding Bootcamps.